Okay. So, we have discussed about the simple harmonic motion, is that means there is no external force applied on that motion circuits. So, in that case we draw the figure like this, that I have a spring, then I have a mass, and there is no external force is applied on that oscillation. Now, think about, if that oscillator is oscillating, a friction force will be acting on it. So, what we will do? We said in simple harmonic motion, the amplitude of oscillation will be remain constant throughout the oscillation. Now, if you have seen that if mass is oscillating and if the friction force is applied, then oscillation amplitude will be gradually reducing and it will be stopped. So, that means, if I apply an external force on that oscillation, I oppose the motion of the mass m. External force will be oppose the motion of the mass m. So, that means that if this mass is motion is particular velocity is u, the velocity motion is u, velocity is u, then applied force, it may be a friction force, it may be a viscous force for liquid. So, whatever that applied force will be oppose the motion of the mass. Okay. That is called damped oscillation. That means, as if I am employing a mechanical resistance to that oscillation, and mechanical resistance is called Rm. So, in this circuits, what I am doing? I oppose the oscillation. That means, I am applying, as if I am applying a mechanical resistance to that motion. Okay. So, that the that force which is applied to oppose the motion is directly stop that motion of that mass. So, that force is proportional to motion of the mass u, it will be negative. Force is oppose the motion proportional to u. So, force, that force is nothing but equal to mechanical resistance into the velocity. So, what is the velocity? In term of displacement, dx by dt. So, now earlier if it is simple harmonic motion, it is m into d2x by dt square plus sx is equal to 0. Now, I said there is a friction force acting on it and it creates a mechanical damping. So, I put another term which is Rm dx dt plus Sx is equal to 0. So, in case of damped oscillation, m d2x by dt square plus Rm into dx dt plus Sx equal to 0. Okay. So, this kind of damping arrangement is used to oppose the motion. Can you give a practical real life example of this kind of things? Think about your suspension of your bike. Why the bike requires a suspension? Why the car, if you ride on a car, every car has a suspension system. Why that suspension system is required? So, why it is required? Now, if you see that suppose you are traveling on a road, let us say it is horizontal force. Now, suddenly road is not plain. So, if there is any bump, it creates a vertical force. So, if it creates a vertical force, then what will happen? Whole bike system is a mechanical body. So, it is nothing but a spring mass system. Okay. So, you feel a vertical direction oscillation. If I applied a force vertical direction and oscillation. So, if I feel a vertical direction oscillation, what will happen? That you will be move up and go down, move up and go down. So, that is uncomfortable for your journey. So, what I required? I required a suspension system which can drive down that oscillation. So, mechanical damping, that is why it is suspension is nothing but a mechanical damping, that is why the picture is like that. So, there may be a air suspension, there may be a spring suspension, there may be a liquid suspension. So, different kinds of suspension system is there. Think about the landing of a plane. when a plane is landing on a runway, so plane is landing on a runway, once it touches the ground, it also get a reaction force towards the vertically up. Okay. So, plane is oscillating in the ground and vertically up. So, that is why I require a real suspension system that can absorb that vertical oscillation. So, that is called plane landing suspension gear. If you see that if the weight is now, if the mass is high, then oscillation frequency will be high. So, you require to initially stop down. So, your mass has to be, the plane has huge mass, your suspension should be that capacity. Similarly, car, similarly bike, everybody has a suspension system. So, that is nothing but a mechanical damping. Now, you have to know, so now equation of the motion of that oscillator, it is damped oscillator, it changed. We have introduced another term which is called mechanical resistance, which resists the motion of the mass. Okay. Now, if you see, if this is the equation, can you tell me what is the unit of that Rm? What is the unit of Rm? How do you express in Rm? What is the unit of force? Newton. What is the unit of speed? Meter per second. So, it is nothing but a force by u. So, it is nothing but a Newton by meter per second. So, it is nothing but a Newton second per meter. So, the unit of Rm, mechanical resistance, is nothing but a Newton second per meter. So, that will be unit. Now, instead of same thing, same solution principle I should apply. So, it is also a second order differential equation. This damped oscillation is also a second order differential equation. So, just first simplify it. So, it is nothing but a d2x by dt square plus Rm by m dx dt plus s by m x is equal to 0. Same things I consider. Let us omega 0 is nothing but a root over of s by m, or s by m is nothing but a omega 0 square, and beta, another constant, beta is nothing but a Rm by 2m. If I consider, then this equation becomes d2x by dt square plus, it is 2 beta, Rm by m is there. So, I can write 2 beta dx dt plus omega 0 square x is equal to 0. I just simply m I reduce and I just put some constant. Now, this is also a differential equation with the second order. Let us, the solution of the differential equation is x is nothing but a e to the power j omega 0, or let us not j omega 0, let us, the solution is an exponential solution, its solution exists gamma t. This differential solution exists a solution which is x is nothing but a e to the power gamma t. So, I have to find out the value of gamma and a. Now, if this is the solution, it supports this equation. So, what is dx dt? A gamma e to the power gamma t. What is d2x dt? dt square a gamma square e to the power gamma t. Now, if I put these things in this equation, equation number 1, what I will get? d2x by dt square. So, it is a gamma square e to the power gamma t, 2 beta dx dt plus 2 beta a gamma e to the power gamma t, okay, plus omega 0 x, omega 0 square x is nothing but a e to the power gamma t is equal to 0. So, a e to the power gamma t is common to all. So, I can write gamma square plus 2 beta gamma plus omega 0 square is equal to 0. This term is 0 and a e to the power gamma t is equal to 0. Okay. So, if this term is 0, what is the solution of the gamma? I can write gamma square plus 2 beta gamma plus beta square is equal to beta square minus omega 0 square. I add beta square this side I add beta square, and omega 0 is this side minus omega 0 square. Okay. So, it is nothing but a gamma plus beta whole square, beta square minus omega 0 square. Okay. So, gamma is nothing but a minus beta plus minus root over of beta square minus omega 0 square, simply. Okay. This is the gamma. So, I can see the gamma is in the form of, gamma is nothing but a minus beta. So, x is e to the power minus beta plus minus root over of beta square omega 0 square into t. Okay. Now, let us consider that omega d is nothing, omega d square is equal to omega d square equal to omega 0 square minus beta square. That means, if I employ a damping circuit, the modified natural frequency is natural frequency, natural resonance frequency when the damping circuit is not there, omega 0 is root over of s by m when the damping circuit is not there. So, omega 0 is the natural angular frequency when damping circuit is not there. If omega d is the new natural resonance frequency, is nothing but a old natural frequency minus beta square. So, I can write omega d is nothing but a root over of omega 0 square minus beta square. So, if I put that things in the gamma, so gamma is nothing but a minus beta plus minus j omega d. Minus sign will come on. So, the root over of minus 1 means j. So, plus minus j omega d. So, I can write that x is nothing but a e to the power minus beta plus minus j omega d into t. So, a will be there. So, a will be there, a is there, I put the gamma value. So, x is a into e to the power minus beta into e to the power plus minus j omega dt. Think that, beta t. See that the amplitude part is multiplied by a exponential, negative exponential term. So, what is that meaning? If I negative exponential, what is the negative exponential term? It will be gradually decay down. The curve of a e to the power minus a is nothing but this one. So, if this is t, so if beta value, depending on the beta value, it will be gradually damping down. So, the amplitude will be reduced over the time. So, amplitude is not constant, that is why it is called damp oscillation. So, beta is nothing but a damping factor. Depending on the beta, how quickly it will amplitude will be die down, it will depend on that things. Okay. So, now another time you have another terminology is there, which is called characteristics time, which is called characteristics time. What is characteristics time? It is defined as that if an oscillation has an amplitude a, damp oscillation, initial amplitude is a, it is the time required to reduce that amplitude by 1 by e factor. So, that means, if let us tau time is, let us I have an amplitude a and tau time is taken to reduce the amplitude by a by e, that is tau is called characteristics time or relaxation time. Okay. Now, then if it is, what is the amplitude? A, let us a e to the power minus in at t equal to tau it is minus beta tau, minus beta tau. That means, if the amplitude is A, this factor must be equal to A pi as per the definition. So, A cancel. So, minus beta tau e to the power minus beta tau is nothing but a e to the power minus 1. So, tau is nothing but a 1 by. So, characteristics time is defined as 1 by beta. Now, if the beta is what? Beta is nothing but a Rm by 2m. So, it is nothing but a 2m by Rm. So, now think about if mechanical resistance is increases, tau will be decreases. That means, if my suspension system is very good, then very quickly amplitude will be reduced. Amplitude will be reduced. If my suspension system is not that good, it requires the time to reduce the amplitude. So, depending on the value of beta, beta is Rm by 2m e to the power minus beta t. So, that if the beta value is very large, quickly decrease, beta value is very small, it requires time to decrease the amplitude. So, depending on the beta value, I have a condition whether it is overdamped or underdamped. So, there is a condition called overdamped, underdamped and critical damp. You have heard about that things. I am not going details on that overdamped, underdamped and critically damped. Only in case of so physical meaning is that if beta, depending on the beta value, how the damp oscillation will be behave, it is depend. So, if the beta is very high, amplitude will be very quickly fall down. If beta is very low, it requires longer time to fall the amplitude. Okay. So, depending on the suspension, that is why BMW car and normal car suspension system is different. That is why if you ride on a BMW car, you cannot feel that there is a road has some bumper on that, because in that case the suspension system is very good. Our general car suspension system may not be that good, that is why you feel a jerking on that car. If you heard about the tractors, have you ride on a tractors? No suspension system, only the driver seat suspension system. So, if you ride on a tractors, jerk is very high. Okay? I am not going that the details of that underdamped and overdamped condition. So, if I say the system is critically damped, in that case, if it is critically damped, that means beta omega d is equal to root over of omega 0 square minus beta square. If I say it is a critically damped, then the beta value is equal to, or omega d is equal to, so in case of critically damped, what should be the condition? We said beta is equal to nothing but a omega 0, because in case of beta is equal to omega 0, then omega d is equal to 0. So, there is no damp oscillation, there is no damp oscillation. So, that is why it is called critically damped. Similarly, there will be overdamped and there will be underdamped condition. Okay. Now, we go for another thing. This is the damp oscillation is okay. Now, think about our requirement. Any system, mechanical system is not a very good, very simple harmonic motion. It has a damping. Okay. So, I have a damping oscillation system. How it will be oscillated by an external force? Think about the loudspeaker. Loudspeaker has you see the loudspeaker has a membrane. The loudspeaker has a diaphragm. Diaphragm is nothing but a mechanical system. It is suspended on a cage and so it is a tension, it has a mass, and it is a damping factor also. Now, if I apply a electrical circuit, I want that membrane should be vibrate as per the electrical signal frequency. So, that is called forced oscillation. I have a mechanical oscillatory circuits, I apply a force on that oscillation, so that that oscillation can give me a constant oscillation as per the force frequency. So, if you see really in this force oscillation, we have two parts. Initially, there is no external force, no oscillation, system is in rest condition. When I apply a force, then and there it cannot be oscillate as per the force frequency. So, there should be a transitory portion from rest position to when it will be steady state, then as per the force frequency will be oscillate. So, to reach that steady state, I require there is a transitory portion. So, transitory portion, force oscillation is a two part, transitory portion and steady state portion. So, at steady state portion, when I drive that mechanical loudspeaker is in the rest condition. Initially, then and there it cannot go to that oscillation which is has the applied force oscillation. So, it requires some time to reach the steady state. Once it reaches the steady state, the oscillation of that mechanical system will be at per the frequency of the applied force. That is I want. Okay. So, force oscillation has a two solution, one is called transitory part, another is called steady state part. So, now forget about the transitory part. Transitory part is the same solution which I apply in that force is not there, and I can get that solution. Now, think about the steady state part, which is called force oscillation. That means, if I want a diaphragm should oscillate as per my applied electrical signal frequency. Okay. So, what I said in force oscillation, that this oscillator at steady state will be oscillate as per the applied force frequency. Okay. So, let us force F is nothing but a e to the power j omega t applied force, I can say, or instead of a I write capital F. Capital F is the amplitude, e to the power j omega t. Omega is the frequency of that applied force. I said in steady state the oscillator also oscillate in the same frequency. So, I can write the x is nothing but a e to the power j omega t. A is the displacement amplitude and omega is the frequency of the oscillation. Okay. Now, what is the equation of this oscillation circuits? It is nothing but a m d2x by dt square plus rm dx dt plus sx is nothing but equal to the applied force F e to the power j omega t. Okay. At the steady state condition. Now, if I put the value of x in here, so it is nothing but a m minus a omega square d2x dt square I can calculate from here plus rm j a omega, okay, into there will be e to the power term e to the power j omega t into e to the power j omega t plus s into a e to the power j omega t, okay, is equal to f into e to the power j omega t. Is okay or not? Okay. Now, e to the power j omega t, e to the power j omega t will be cancelled. All are there. So, it is minus a m omega square minus a m omega square plus r m j a omega plus s a is equal to f nothing but a f. So, if it is that, then what is the value of a? A will be, what is the value of a? A will be f by minus m omega square minus m omega square plus j r m omega, j r m into omega plus s is okay, plus s. Now, if I simplify that thing, I take the j omega is outside, then it will be f by, I taken j omega outside. So, it will be r m will be no j omega plus s will be s j omega, s into or s by j omega, s by, sorry, it will be s by j omega minus m by 1 omega, m omega square by j omega. Okay. So, 1 omega will be cancelled. Okay. So, it is nothing but a f by, I am not j omega r m plus s by j omega minus m omega by j. Okay or not? Okay, because 1 omega is cancelled, so m omega will be there, by j will be there. Now, since the j I have to, if I take the j is outside, so it is nothing but a f by j omega r m plus, j is outside. In case of j is outside, so I am multiplying both in j. So, j square means minus 1, okay, and here j square means minus 1. So, it will be plus 1. So, in case of plus 1, so it is m omega minus s by multiplying j up and the j square, j square is nothing but a minus 1. Okay. So, it is f by j omega r m plus j omega into m. Now, what is x then? So, x is nothing but a into e to the power j omega t. So, x is f into e to the power j omega t divided by 1 by j omega into r m plus j omega m minus s by omega. Okay, s by omega. Let us consider, see that this one. Let us consider this part, this r m plus this part. So, this is r m plus j omega m minus s by omega. Let us consider this is nothing but a Zm, which is called mechanical impedance. Zm is nothing but a mechanical impedance, which has a resistive term, mechanical resistance, and has a mechanical resistive term, mechanical resistance and mechanical reactance. Okay. So, total impedance, resistance plus reactance. Okay. So, resistance is real part, it is the imaginary part. So, I can say this is R and this is Xm. So, I can write Zm is nothing but a R plus J Xm, where Xm is nothing but a m omega minus s by omega. Is okay? Now, this is the Zm. Now, then what is u? This is x. Then what is u? u is nothing but a dx by dt. If I dx by dt, j omega will be come here. So, j omega will be cancelled. So, it is nothing but a f by Rm plus j into omega m minus s by omega. Is okay or not? Okay. Think about what is this. So, u is nothing but a f by, this is nothing but a Zm, f by Zm. So, Zm is nothing but a, okay. So, if it is mechanical impedance, what is the unit of mechanical impedance? F by u, force by velocity. So, it is nothing but a Newton by meter per second. So, it is Newton second per meter. Okay. So, mechanical impedance is nothing but a applied force divided by the particular velocity or motion of that oscillator. Okay. Now, I can write in Z in different form also. That we should have understand that I can write in the Z in different form. So, I can write if Z is nothing but a plus or R plus J xm, R plus J xm. So, I instead of that I can write there is amplitude part mod Z, which is nothing but a root over of R square plus xm square. Okay. And or write Zm, I should write Zm, mod Zm, and angle theta, I have an angle theta. So, theta is nothing but a tan inverse xm by r. R is nothing but a Rm. So, it is nothing but a tan inverse xm is omega m minus s by omega divided by Rm, and it is nothing but a Rm square plus m omega minus s by omega whole square. So, if I know a mechanical system Rm, S and M, I can find out the mechanical impedance, amplitude of the mechanical impedance. Okay. Again, I can find out the angle of the mechanical impedance. So, angle means force and velocity has an angle which is theta. So, theta is nothing but a tan inverse this thing. So, I can write Zm, instead of writing Zm is mod of Zm into e to the power j theta, e to the power, where theta is nothing but a tan inverse xm by Rm, xm by Rm. Okay. Now, if it is that, then what is x? I said x is nothing but a f by 1 by j omega Zm into e to the power j omega t. This is the x, 1 by j omega f into the power j omega t divided by Zm. So, instead of Zm, I can write j omega f e to the power j omega t divided by mod of Zm into e to the power j theta, mod of Zm e to the power j theta. So, this is nothing but a 1 by j omega e to the f into e to the power j omega, e to the power j omega t minus theta divided by mod of Zm. Okay. Now, e to the power j theta cos theta plus j sin theta. So, I can express this term 1 by j omega into f into cos omega t minus theta plus j sin omega t minus theta divided by mod of Zm. Okay. Now, if I say what is the real part of x, real part of x, if I want to find out real part of x, this will be imaginary part then, and the second sine term will be the real part, j cancel, sine term will be real part. So, real part is nothing but a f by mod of Zm into omega, 1 by j omega, j cancel, omega will be there. So, into omega sine omega t minus theta. So, this is the real part of the x. Now, what is the real part of the u? Similarly, real part of the u, I can also find out real part of u from the u equation is nothing but a f by mod of Zm into cos omega t minus theta. Okay. So, I can take the u equation and take the real part e to the power omega t minus theta. Okay. So, sine displacement is in sine function, velocity is in cos function. Okay. Now, if I want to find out, so what my intention is to find out the power. If it is forced oscillation, what power it is delivered. So, if I applied a force F, how much power it is delivered by the oscillator. That is why it is forced oscillation. So, I can say let's instantaneous power is pi I. Any moment power is nothing but a force multiplied by the speed. Speed is nothing but a displacement per unit time. So, any moment, what is the force acting on the oscillator? Force multiplied by the displacement is the work done. Power is force into displacement is the power. So, it is speed multiplied by the applied force. So, I can say that it is nothing but a force F e to the power j omega t multiplied by u, speed. Okay. So, what is speed? F e to the power j omega t. What is the real part of the speed? F by mod of Zm cos omega t minus theta. So, it is nothing but a f square, or what is the real part of the force? Instead of e to the power, f is e to the power j omega t. F force is nothing but what is the real part of f? Real part of f is nothing but a f cos omega t. So, instead of complex part, I should write cos omega t into u. So, it will be cos omega t. Real force multiplied by the real speed is the power, instantaneous power. So, instantaneous power is f square by Zm into cos omega t into cos omega t minus theta. Minus theta. Okay. So, this is instantaneous power. Now, instantaneous power in real life application, we are not talk about the instantaneous power. Instantaneous power, I do not know in which time, at any time the instantaneous power. So, we said a term called average power. We said a term called average power. Then what is the average power? How do you calculate the average power? What do you mean by average power? Suppose I have a sine wave, I want to calculate the average energy. So, I said since it is a periodic, within a one period, how much power is there divided by the length of the period is the average power. So, I can say that average power is pi is nothing but a integration over 0 to t is the period divided by 1 by t. Okay. Integration over the period of what? Of the instantaneous power pi I dt. So, if it is instantaneous energy is pi I, then average energy is nothing but an integration of that pi I over a time period of 0 to t divided by the total time period. Okay. So, if I do that integration putting the value 1 by t 0 to t f square by mod of Zm cos omega t into cos omega t minus theta dt. Okay. If I do this integration, I will get f square by 2 Zm cos theta, cos omega t minus theta, cos A minus cos B, expand it and do the integration, you will get f square by 2 Zm mod of Zm cos theta. Same as if you see, if I apply a voltage, a current, total power is V I cos theta, V I cos theta, cos theta, theta is the power factor, angle between the voltage and current. Here also if I apply a force F, power is force multiplied by the velocity and power is nothing but a V I, same F into U into cos theta. Cos theta is nothing but a as if power factors. So, theta is the angle between the applied force and the velocity. In case of current, theta is the angle between the voltage and current. Okay. Now, if it is cos theta, then what is value of the cos theta? What is the value of the cos theta? If you know what is theta, theta is nothing but a tan inverse xm by that things, and so I can say that if it is mod of Zm is nothing but a root over of Rm square plus that xm square, we have xm is nothing but a omega m minus s by omega. Okay. And theta is tan inverse that things. So, theta is nothing but a angle between the force and velocity, and which has an hypotenuse, that hypotenuse is this one. Okay. And base is nothing but a Rm. So, cos theta is nothing but a Rm by mod of Zm, Rm by mod of Zm. So, if it is Rm by mod of Zm, then power, total power, average power is equal to f square by 2 Zm cos theta. So, I can put the value of cos theta f square by f square into Rm by 2 mod of Zm square, Rm by Zm, mod of Zm square. Now, see that equation, f square into Rm by 2 Zm square is the equation of the average power. When will be the average power maximum? When the Zm will be minimum. If Zm is minimum, average power will be maximum, or mod of Zm will be minimum, then the average power will be maximum. What is mod of Zm? Rm square minus m omega minus s by omega whole square. So, this term I cannot minimize this term. So, if this term is equal to 0, then I can say Zm is minimized. It is a term of omega. So, at certain omega, if this term is equal to 0, then I can say Zm is minimized. So, Zm will be minimum when this term equal to 0. When this term will be 0? When this term will be 0? M by, let us m omega minus s by omega is equal to 0. That is the condition I want. So, it is nothing but a m omega square minus s is equal to 0, or a omega square minus s by m is equal to 0, or omega square is equal to s by m, which is nothing but a omega 0 square. So, if the applied force frequency is equal to the resonance frequency of the circuits, then the resonance will be happen and power will be maximum. So, Zm will be maximum, Zm will be minimum when xm is equal to 0, So, when Xm will be 0? At if the applied force frequency is coincide with the resonant frequency of the natural resonant frequency of the circuits, then it delivers the maximum power. So, I get the average power will be maximum. This is called mechanical resonance, which will be discussed in the next class. So, what is mechanical resonance? Okay. Okay.